Assalamu alaikum. Welcome to online support program. My name is Kuratulan Heather from EBS XSQ14. Today I am going to deliver a lecture regarding science for grade 6 and week 5. Today we are going to start a new chapter, unit number 3, particles. Here are the contents: evidence for particle models, evidence that particles exist, evidence that particles are always moving, more evidence that particles are moving, evidence for the spaces between molecules, expansion and contraction. Here are the objectives. Student will be able to classify materials as solid, liquid or gases. Students will be able to describe materials as being made up of particles. Students will be able to use the particle model to explain the existence of particles. Describe that not only particles are very small and numerous, but that they are also able to move. Use the particle model to explain the existence of spaces between molecules. And students will be able to use the particles model to explain the expansion and contraction of solid, liquid and gases. Okay, first of all, you should know that the substances around us can exist in three forms: solid, liquid and gas. We call these three physical states: solids, liquids and gases. First of all, let's have a look on solids. Solids have well-defined shapes. The crystalline solids have flat faces and sharp edges. Like all solids, they keep their shape and do not flow over surfaces. Substances like sand and sugar may not appear to obey these rules, but close examination shows that each grain is a hard solid which has a definite shape and retains it. Next we have liquids. Liquids do not have well-defined shape and they flow over the surfaces. When a liquid is poured into a jar or bottle, it takes up the shape of the container, but only up to a certain level. The liquid has a specific volume which can be measured using a measuring cylinder. Then gases. Gases do not have well-defined shape or volume. When a gas is placed in a container, it quickly takes up an available spaces. Gases can also flow, and it's possible to pour heavy gases from one container to another. Here we have the structure of solid, liquid and gases. In the first diagram you can see the structure of solid that's quite close to each other, and then in the next we have liquid, and the last one diagram is of gases. It means that solids have only well-defined shape. Liquid and gas do not have well-defined shape. Next, we have the particle model of solid, liquid and gases. The particle model of solid, liquid and gases. Scientists have built up a model to help explain how solid, liquid and gases behave. So it's known as particle model and is based on three assumptions. So these three assumptions are: always all matter is made up of tiny particles which are continually moving. Number two is when the particles are close together, they are attached to each other. And the last one, heating a material affects the movements of the particles. So these three assumptions are the uh, assumptions of particle model. The idea that substances are made up of very tiny moving particles is known as kinetic theory of matter. The word kinetic comes from a Greek word meaning moving. There are two kinds of tiny particles, one smaller than the other. The smallest particles are called atoms. Larger molecules are groups of atoms that joined together. We cannot see the individual atoms and molecules in solid, liquid and gases, but the particle model shows how they are arranged. You can see in the diagram. Next we have a model of particles in solid, liquid and gases. Strong forces of attraction hold the atoms or molecules close together in rows. The particles vibrate, but they are not be able to break free. That's why a solid has a fixed shape and volume. A model of the particles in a liquid. Atoms or molecules are held close together, but not tightly, nor in any particular pattern. They have enough energy to move about more than in a solid. That's why liquids can flow. At the surface, the particles attract one another, forming a kind of skin over the liquid. Next, a particle model of gases. Atoms or molecules are far apart and move so quickly that they do not really attract each other. They move in a straight line and frequently collide with each other and the walls of the container they are in. The large distances between gas particles means these gases can be squashed or compressed easily, as shown in the diagrams. Next, we have the evidence for the particle model. Although we cannot see individual atoms and molecules in solid, liquid, and gases, there is a lot of evidence to support the particle model. So let's have a look on evidence that particles exist. Have you ever noticed that how a balloon always goes down after a while? No matter how tightly the balloon is tied, the air inside always seems to escape. This is because the skin of the balloon has millions of tiny holes in it. The molecules in the air are small, enough to pass from the hole, so the balloon deflates. Let's have a look on the structure of the balloon. Okay, this is the internal structure of balloon. Right, we have air is made up of millions of tiny moving molecules. Then balloon skin has tiny holes in it, and after a week you can see that balloon always deflates and it looks like a useless. A few of the molecules escape through the holes, and inside it you can see that there are small particles, and the balloon skin, that is the magnified picture. So in simple words, we can say that the air inside the balloon is always escaping because of having millions of tiny holes in it. Next, we have evidence that particles are always moving. When you take the cap of a bottle of perfume, the smell gradually spreads out. After a few minutes, the scent can be detected several meters away. This is because some of the perfume molecules have escaped and moved across the room by colliding with the moving air molecules. One substance spreading through another is known as diffusion. So in simple words, we can say diffusion is the movement of molecules from one place to another. More evidence that particles are moving. We can get a better idea of how particles move by looking at small particles of smoke suspended in air. The small glass container called a smoke cell is filled with smoke and illuminated from one side on the stage of a microscope. Through the microscope lens, hundreds of tiny bright specks can be seen jerking about in all directions. The bright specks are smoke particles and they move because they are being bombarded by the molecules in the air. And these are the moving molecules. This random motion is known as Brownian motion, and it is named after a Scottish scientist, Robert Brown. In 1827, Brown noticed that pollen grains moved jerkily when placed in water. In this case, the tiny pollen grains were being bombarded by moving water molecules. Next, we have evidence for the spaces between molecules. When 50 centimeter cube of water is added to 50 centimeter cube of water, we get 100 centimeter of water. It's an obvious thing. However, when 50 centimeter cube of alcohol is added to 50 centimeter cube of water, we can only get 95 centimeter of the mixture. How? How can we explain the missing volume? Remember that molecules in liquid have spaces between them. When the alcohol and water are mixed, water molecules fit into some of the spaces between the alcohol molecules. This then makes the volume smaller than you are expecting. You can see the model, and this model is for yourself by mixing 50 centimeter cube of rice with 50 centimeter cube of peas. Shake the two things together and look at the final volume of the mixture. So this is your task. You can do it by your own self. Next, we have expansion and contraction. Solid, liquid, and gases all expand, and by expanding, they get bigger. When they are heated, when they cool down, the opposite happens. They contract, it means they get smaller. This happens because heating gives atoms and molecules more energy. This causes them to move faster and bump into each other more often and with a greater force. This makes them move further apart. The increase in space between molecules or particles is the reason that why solid, liquid, and gases expand. Gases expand more than liquids, and liquid expand more than solids. When they are cooled, the atoms or molecules lose energy. They move closer together, resulting in contraction of the solid, liquid, or gas. The joints between railway lines have a small gap called an expansion joint. This joint always allows the metals rails to expand into hot weather, otherwise they would buckle. Here we have the diagram of expansion in solids and expansion in liquids. Look at the first figure. Uh, Here we have a metal bar. When the metal bar is cold, it slips into place. And after it has been heated, the bar is too big to fit in. And in the next diagram, expansion in liquids, we have a water containing a dye. When the flask is put in hot water, the water inside expands. Just look at the flask before heating and after heating. So here is the end of the chapter. Let's recapitulate what we have studied today. Today we have learned evidence for particle model, evidence that particles exist, evidence that particles are always moving, evidence or more evidence that particles are moving, evidence for the spaces between molecules, and in the last, expansion and contraction. Here is the assignment. What you have to do is you have to do thorough reading of pages 33, 34, 35, 36 and 37 of your textbook. Then you have to do question answers or test yourself on page number 36 and 37 on blue sheets. So here's the end of today's lecture. If you have any query regarding this, so you can ask me in group. Thanks.